Okay. I see what's going on here. This is not really like a usual design. So our boy here is using emojis as variable names. This is the first on this series. I actually don't know how to react to that. What's up guys, my name is Cherno. Welcome back to my roast review series. I mean code review series. For some reason I got roasting on my mind. Coming in hot, there's that roasting again. We've got Aaron. Hi Cherno, it is a pleasure to meet you. I'm looking forward to getting roasted in your channel. There it is. I'm very excited yet nervous at the same time, as you can see. Hopefully, I won't regret writing this. Here is the link. We'll look at that. And I'll have that link for you guys in the description below as well. Thank you for your time. Hope you have a wonderful time roasting, as it's your job, so do it well. This really should be roast review or something. Just roasting, I think, the name of the series, roasting. From a exclamation mark nickname. Okay, so this cute farm game that we have here was kind of looked interesting. That's why I picked this one, if you guys want to know. It kind of reminds me of like Stardew Valley, maybe. I just thought it would be fun to look at like an actual game, like an actual project here that's not just like doing one thing, but something that is more or less playable, hopefully. So let's have a look at the link. Okay, so here we go. So it's got a README, which is good. It's good step one. It's got some instructions on how to compile the project, which is great. To compile project, all right, I'll stop. To compile the project, so we go to the source directory and make in terminal. Oh, there goes like my mood for the day. It's all right, we'll keep going. So you will need to install a GCC compiler and make. Oh, it's getting worse. How to play. Okay, and then there's how to play. Okay, let's talk a little bit about this whole project compilation process. Using make directly to compile is not like the worst thing in the world, obviously, but I will say it is definitely the worst thing on Windows. Also, you will need to install a GCC compiler or compiler. So the ideal scenario here would be to not enforce any specific compiler and to not enforce a specific build system, in the sense that like make is a build system. It will use a compiler to actually build your project. If you had used something like CMake, then you have the option to generate make files and use make to compile it, which would potentially be a fantastic option on Linux, but then I could also use CMake to generate myself a Visual Studio solution and then go through that build system and that process instead of having to use make. Because using make on Windows is not exactly, you know, native, so to speak. It's not like using make on Windows is unnatural, right? It's not something that we generally do ever. Now, why is this whole Windows scenario even an issue? Like, what if this is just a Linux game? Well, first and foremost, Windows is always like, you know, the largest market when it comes to video games. So in general, my advice to anyone making any kind of game is Windows support is basically mandatory. Ideally, of course, you would support Windows, Mac, and Linux. Like, why not support everything? And to be completely honest, these days, it's not very hard to do that. But not having Windows builds as like even a natural option over here is already a bit of a red flag for me. But what if this is a Linux game? You know, well, like, sure, maybe Aaron here has made a completely, like, he's made a Linux game. Maybe he doesn't have a Windows computer. Yeah, absolutely. Let me rebut that, because first of all, I noticed this, right? Rename aaron.exe to game.exe. So this is some Windows behavior here. This is some Windows language going on over here in this like commit message. But then also over here, we have the itch.io page for Qt Farm. And if we go to that itch.io page, what are we gonna see, do you think? Oh, we're gonna see a downloadable zip folder for which platform? Guys, I'm having a little bit of trouble recognizing this logo here. Is this Mac OS? Anyway, so this is clearly, I don't know, Windows only? I just don't understand, like, honestly, what's happening here. And if you are in fact on Windows using Make and GCC, GCC is fine. You know, use GCC instead of MSVC or Clang, whatever, you do you, but Make on Windows, let me know what you guys think in the comment section below. Am I being too harsh and too roasty, or is that absolutely ridiculous? You know what's not ridiculous though? Brilliant.org, the sponsor of this video, has an amazing 30-day free trial that you can use to check out their entire platform. For those of you who don't know, Brilliant.org is a great website filled with lots and lots of really high quality courses on various STEM topics. They're a fantastic way to get started with computer science, and the reason why I say that is because they don't start with a particular language. I think learning the core concepts of programming, learning how to think like a programmer, that is really the most important thing in the beginning. And Brilliant do that super well with all of their visual, engaging, and interactive courses. purposes. So for example, instead of just watching videos, you'll be dragging around these widgets here to play with numbers and also to define like the control flow of the program. But then of course, once you've got that down, you can progress onto a real programming language like Python. This super effective way of teaching also translates directly into their beautiful math courses. All the way down to the very beginning through to topics such as calculus, learning that kind of stuff just benefits so much from this way of teaching. And as I mentioned at the start, Brilliant have a 30-day free trial that you can use to check out their entire platform. Just go to brilliant.org/thecherno, link will be in the description below, or you can use the QR code on screen. If you do go on to like it, that link will also get you 20% off an annual premium subscription. Huge thank you to brilliant.org as always for sponsoring this video. Anyway, back to the code review. So it's amazing how often I get to this phase in the code review and there's already issues with just like this. This is like, yeah, I don't know, in my mind, this is like the first step. Like the first step is get your build system sorted out, get your project like configuration, all that meta stuff sorted out, have a really easy way to build this stuff for your target platform, and that's it. Right? Like, cause I don't know how I'm gonna build this. I don't think I have got Make installed. Okay, so here's a project. I've checked it out. It's on disk right now. If I try and build this, well, I don't have Make installed. So I'd probably have to go and get Make. However, I did notice that there was, that executable in here. So I don't know, guys, risky click of the year. Do I run this? You know what? Let's do it. Let's do it for you guys. Let's do it for the fans. All right. Oh, that's all right. The virus doesn't even work, so it's fine. Okay, so we've got some like GCC library stuff not found. Okay, cool. And then yeah, WinThread, whatever. So we can't actually run it using this. I guess we could try download this. All right, I'm just gonna unzip that over here. This is what was in that zip file. Got our assets here. Don't see those DLLs though. So I'm assuming that when I run this, same issue. All right, cool. So we're at a situation here where I basically can't build this natively on the platform that it's seemingly designed for, but then also I can't download and play this. All right, Aaron, it seems we have come to a somewhat familiar place for this series where I have to ask you to respectfully please try again. Please fix all of this stuff, and then hopefully I'll be able to play your game, because as I mentioned, it looks nice. I mean, I know you didn't make the assets, and I guess that's kind of what we're seeing here. I'm sure the programming is also very nice. It looks nice, and I'd like to play it, but there's too much friction here. There's just too much friction between me and this game. And of course I could fix it. By the way, one other thing that I noticed is that in the lib directory, we seemingly don't have any like Windows binaries here. Right? Like this is the DLLs and everything, they're missing. They're not inside this directory. So that's definitely adding to my confusion. But anyway, please fix this and I will re-review this possibly like as an actual game. However, we do of course have all the code here, so we can still do a code review on it. But so far, your score is -1 out of 10. And it's not like a uint 32t where -1 wraps around to max value and therefore max value out of 10 means the code is really good. That is not what I'm talking about. It's a signed integer and your score is -1 out of 10. All right, in comes Visual Studio Code with this project opened up, well, with this folder opened up, right? So let's have a look at the code. I'm guessing the main.cpp is probably the main file. Okay, so this is an interesting main file, right? Because we don't have a single include. We have this like function declaration, which we're then calling. We don't have a return 0, which is perfectly fine, by the way. I'm actually kind of almost glad to see that. It's funny how so the absence of like a return 0 either means that this programmer knows what they're doing or has no clue what they're doing. It could go either way, but I'm gonna give you the benefit of the doubt here. Okay, so like this is like fine. What do I even say about this? There's really not much to say about this. So we're calling a function called game, obviously, and that function is not present here within this translation unit. It's going to be somewhere else in our project. It's a little bit like not typical to do something like this, because usually what you would do is you would include like, game.h or game.hpp in this case, and then this header file would have that declaration in there. And the reason we do that usually is just because it keeps all of our function declarations organized within a file that relates to that system, essentially, or those functions that we're exposing. And that of course is particularly useful if you're trying to use those functions in more than one CPP file. Now this is a bit of a special case because I'm assuming that this only ever gets called within this file. So maybe the author has just decided, let's manually put this here. But Still, I don't think this sits that well with me. I probably would just put it into game.hpp. Maybe it's actually not in there because this is a game class. So maybe it's actually not in here. So, okay. So see, this is another reason why this is annoying, right? Because now I'm like, okay, well, where is this function? Like, I actually don't know where this function is located. I can use like IntelliSense, like the C++ plugin in VS Code. You can see if I control click, will actually take me here. Of course, it's in a file called file.cpp. That was my second guess after game. And also, am I seeing things? So our boy here is using emojis as variable names. This is the first on this series. I actually don't know how to react to that. Wow. And this function is just amazing. Okay, so why? What? I gotta stop saying why. We got this file here called file.cpp, which has a single function in it called game, and it creates an instance of the game class here, and somewhat sets up the game, but I just don't know why this exists. The asymmetry here is a little bit weird as well because we're initializing the window here, but like where are we shutting down the window? We're not actually seeing that. Now that could be in game, right? Game does have a destructor, but it doesn't shut down the window. Oh, okay, so the end of the run loop, this really should be on a new line though. The end of the run loop here does actually call close window, but the trend here, like the first thing that I want you guys to notice here is that it's just the complexity already of the flow and the organization of this project, which, complexity might be a strong word because it's obviously not that complex, but it's still way more cryptic than it needs to be, right? Like this is your main function. I would just do this. This is your main function, literally. It takes 2 seconds to just change that to main. And at the very least, you have a much clearer program, but also init window and set target FPS. I don't know, maybe I would put that into the game class potentially. I don't really think this needs to be a class either, because this is obviously the place. I guess I'll go back to the OG code. By the way, before I do that, I just want to also shed some light onto one of the reasons why this is suddenly more clear, right? Is because init window set target FPS, they're coming from raylib.h. We can clearly see that being included here. Game, that's coming from game.hpp. This main function, is supposed to be this thing here from which our entire program stems, and we can see these connections. Whereas before, when we didn't have this, it was a little bit murky. So that's like one of the differences that I'm talking about. Okay, we're back to where it was. But then the reason why I say game might not need to be a class here as well is because game, you can see it's not used anywhere. So we create it here, but then we don't call run game, or we don't really do anything with that actual object. So the fact that it's even getting created like this already looks a little bit weird. Now, a rebuttal to that might be the fact that game actually stores data as well, right? And you can see it does, because we have game, which just has a public constructor and a destructor, which again, I will say that this is not really like a usual design. But anyway, it's got a constructor and a destructor, and then it's got a whole bunch of private members and private functions. So the idea is literally the fact that the game constructor will call, run game, and it will just block there on that thread while the game is actually running. And so we're sitting here blocked by this while loop, and that's why we're sitting on this line of code and we're not advancing to this, because as soon as we get past this line of code, that's it. That game is going to get destroyed. So what happens is when this window should in fact close, this switches to true. That's at which point we close the window. And then now, since run game is not blocking us anymore, we progress to the end of the constructor. The end of the constructor is called. So we're back here now. We'll go to the end of this function because we finished this function. And then that calls the game destructor, which is over here at the end. This is another weird thing, right? We got the constructor as the first function, the destructor at the end. I'd probably have them like together. And then we'd like destroy the tiles, and that's it. It's the game's over, like literally the main function ends, that's it. So yeah, I mean, look, this is kind of like a unique life cycle. Haven't seen this exact thing before. I think I put up a video somewhat recently where I was kind of advocating for this notion of like constructor is fine to like initialize stuff, like to actually like start your game or whatever, and then the destructor can clean that up. And the benefit there is that you don't have to deal with like calling individual functions. This is probably a very extreme use case because this obviously does a lot on this line of code. I mean, the whole game runs on this line of code, and it could definitely benefit from some clarity. Even something as simple as calling run game. So run game is currently private, but if you at least had this function being called here, if it was public and not doing it in the constructor, at least adds like some kind of notion of, okay, this isn't just creating the game as in like it's allocating some memory, creating data, doing whatever it needs to do to initialize the game. It's actually the thing that runs the game. I think that would even enhance this a bit. But yeah, I could definitely see some people liking this potentially because it obviously keeps stuff very clean. So yeah, I'm kind of undecided on this. I can see benefits of both, but as I mentioned, I do think this is leaning a little bit into the extreme case of like, this is just a little bit opaque and it's not clear enough as to what's going on. And I also definitely don't like this part of the initialization being outside here in this function. That's kind of weird as well. Now the game header file is also very interesting in the sense that it's actually loading textures and images. It's doing a lot of function calling and like, I would say strong initialization inside just like the header file by just initializing member variables. So that's definitely something I wouldn't do. This needs to be debuggable and you need to be able to recover from potential errors that happen with this. You obviously can't add any control flow code to this area of your code here because this is where we declare variables. So I would not have any of these here, but instead I would, I don't know, possibly have this in some kind of like, you know, load resources function that would contain these things here. And then of course you could just rewrite the code like that so that you're going through and you're loading these things and then you can of course respond to them. So if that like doesn't get loaded or whatever else, you could log an error. I mean, the AI is like helping me over here. And as it's suggesting over here, you could also potentially just terminate the application or be like, hey man, I haven't found the resources, I can't play. But in this case, what's going on is I'm guessing that will just return like an empty texture struct or whatever. I'm not sure what state this is in. If it doesn't get loaded, probably just an invalid like texture ID. And then you're going to continue playing the game and it's probably just going to silently crash and it's not going to tell the user or the player why it crashed or what went wrong. It's just probably just going to crash. Whereas if you had this code in an actual function that you could add some error checking to, you could at least inform the user that, hey, the reason why you cannot play this beautiful game at the moment is because I'm actually missing some data that I need. So please fix that and then maybe I'll let you play the game. Same with like this, right? So player equals player and then you just initializing this stuff here. It's like super weird and part of me is even telling me that this shouldn't even work, right? I mean, I think, okay. I see what's going on here. Okay, so I think, guys, I've actually worked out why this code is here. Because this code critically needs to run before the constructor of game. The reason why is because you can see that init window gets called. So this actually creates the window. This needs to happen first because as soon as we get into game and we start, like we're over here, we're about to call the constructor, we're in like this kind of variable initialization stage of the constructor. We're gonna go through and in order here, we're gonna start obviously initializing all of our variables. We're gonna load some textures, which by the way, since Raylib uses like OpenGL, I'm guessing in this case, I don't know if it always uses OpenGL, but you can see it says OpenGL texture ID here. It's gonna need an OpenGL context. So it's gonna need like a window with an OpenGL context to even do that loading. But then also like the player uses functions like get screen width and get screen height. And you can't use that if you have no screen because you have no window, because this code happens, for example, here, right? Because our variables get initialized, I don't know, kind of here. And the reason why I say kind of here is because you can literally have an initializer list that initializes that variable instead of what you've written here, like in the header file, right? So that's very, very interesting. And I think that's truly why I think these functions are not over here inside the game constructor where you would expect them to be, but instead outside over here because of that initialization in the header file variable declaration area. So don't do that, fix that. Put this stuff into the constructor or some kind of load resource function for these and like initialization, create game world, create scene, whatever it might be, put it into those functions and then have like the game constructor maybe only deal with initializing like the window and stuff like that. There needs to be, in my opinion, some kind of more clearly defined application architecture. And I do say that a lot, but it's true. Okay, so moving on. So let's go to that run game function, right? Because as soon as we've loaded all this stuff, I'll get rid of my code. Not that we can run this project anyway. When we go to run game, this is where we have our main application loop. Now, I think we probably set the target FPS to 60. So because we did that, that immediately means that we potentially don't really need like the concept of delta time or timers, because if we just lock this loop to 60 frames per second, so we have like 16 milliseconds between runs of this particular loop, then obviously we can use that for timing instead. Definitely not my favorite way to do timing. I much prefer delta time for various reasons, even the fact that you can obviously run this above 60 FPS, which might be preferable if you have monitors that have higher refresh rates than 60. But anyway, I'm just saying that that's probably why we're not seeing any kind of delta time here, because technically we don't need it if we guarantee that it's running at 60 FPS. Now, the other problem with trying to guarantee that something is running at 60 FPS is that might be quite the call to make, because what if the computer can't handle running this game at 60 FPS? What if it ends up running at a 30 or 20? Then obviously the whole game will just slow down, because if you add 1 unit to the player's position per iteration of this loop, and you're now running the loop 20 times per second instead of 60, then you're going to move a third of the distance, right? So everything kind of goes into slow motion, slows down, which is technically a valid way to handle like a frame rate target not being reached. But is it the way that you want to do this? Or do you just want to effectively skip frames by moving stuff more to compensate for the fact that it's running slower? Just things to think about. Okay, so if title screen, we do check input and update game. So title screen is a function also in the game class. Oh, look, we do have some kind of get frame time situation. That's interesting. I wonder why. Oh, because we have, okay, because we're doing some animation, right? So we're doing some animation for this like button or whatever, probably. Again, I can't play the game. And then if the mouse is clicked, we're going to set run to true. We'll also sleep for a second. Oh, sorry, sleep for 1 millisecond. This is microseconds. Why not just say 1 millisecond? Or like, why are you even sleeping for 1 millisecond? This is bizarre. I mean, this is entirely a single threaded application, right? So we're just sleeping for 1 millisecond? Why? Just blocking the main thread for 1 millisecond. Okay, look, I have no idea why that's there, so let's move on. This is kind of an interesting way to handle state. The idea is that this title screen will actually do some rendering for like the main menu, but then also have a button that people can click on that is at a very precisely positioned absolute position on the screen, which already means that you can't really resize this game, unfortunately. Like that should happen. And so if we hover over this destination and we press it, then we set run to true. Now there's no code here, and this is the play button, right? So this is like what we're doing here. I think the reason we're using source and destination here is because source is probably going to be a portion of that texture. So if we have a look at the assets, so we've got objects play, that's the play button. You can see there's different versions of it. So by using this source, we're actually selecting like a region of that texture, and then the destination is where on the window we're drawing it to. And again, because that isn't actually calculating a position, it's just using absolute values, it's not going to work with resizing the screen. But also what I find funny is we obviously run this function every frame, which means that even when you're long playing the game, you're still actually calculating all of this stuff and checking to see if the mouse is hovering over this portion of the screen. So that's a little bit ridiculous. Again, it kind of works as like a, I don't know, I would almost call it like a game jam hack just to get something working. Obviously it's clean in the sense that like you can just be in an immediate mode kind of reactive state where we check to see if we're supposed to draw the title screen or whatever, we draw it if we need to. Otherwise, if title screen is true, then we just continue on with the game. But yeah, it's definitely not going to scale, and it's definitely very messy. It also doesn't quite make sense that it's returning true because title screen implies main menu. However, we return run, which implies that we're running the game, not the menu, which is why if you actually read this in terms of just English, it's saying if title screen, check input, update game. Whereas we only really want to check input and update game if we're not on the title screen. So then why is the title screen returning true mean that we should play the game? Run is also not a local variable. So it looks to me like run is a local variable, right? Because we're setting it here, then we're checking for it, and then we're returning it. So returning a variable is almost like a little bit of a giveaway in a way that makes me think, okay, that's probably a local variable. But is it a local variable? No, it's not a local variable. It's over here. It's in our header file, right? So this is another reason why I like to use naming conventions such as m underscore, because that immediately shows me that, okay, that is not in fact a local variable. It effortlessly adds some clarity to what's going on in this function. Okay, so moving on. So we do check input, which, okay, that actually does do things. I thought that would just like poll the input, but we're going through like all the tiles, I guess, checking to see if we collide with the tile, who's colliding with the tile. the player. So this is also hard coded to just have the player over here and then only check collision between the player and a tile. Really nice to make functions like this generic in the sense that like you can just have an entity colliding with another entity or an entity colliding with a tile. The reason why is because what you need usually to calculate this collision in the first place is something that applies to every single entity out there, right? So every entity is going to have like a position, a size, this hitbox or whatever. So there's no reason to kind of lock this in generically to player. And when you're making games, it's also quite common for you to want to extrapolate on some of these features. So for example, we have a concept of an entity colliding with a tile. It's specifically the player, but in the future, would it be crazy to suggest that there might be other entities other than the player? Like maybe there's like some animal running around the cute farm that needs to also check the collision. No, that sounds plausible. There are stranger things to add to the game called cute farm than farm animals. So the fact that they're also going to need that makes me immediately think, even though I'm not the designer of this game or anything, makes me immediately think, okay, so we have a managed collision, but why is that so narrow? Why is that so focused down to this specific entity that again is a member of this class? I think thinking in kind of almost like a functional programming situation. I don't want to exactly say functional programming, but function-oriented programming almost, where like we have inputs and outputs to functions. Let's think of it that way instead of really tightly coupling this function with member variables. I think that would definitely benefit like the design of this application a lot. And if you guys want me to expand on that, let me know in the comment section below, because that topic is honestly an entire video's worth of information. Okay, utils check collision. So this is kind of nice, right? So we have managed collision, which as I mentioned, just really locks you into player, but then we have check collision, which does generically take stuff in, and it is not part of a member, and it is not part of this class. It's its own function inside the utils, but it does have some game specific logic over here, which isn't ideal. And then check collision rex is a raylib function that we use to just check to see if the hitboxes are overlapping, basically, if the rectangles are overlapping. The way this function is written is honestly a bit horrific. This is my roasting side that you asked for coming in. Okay, let's quickly rewrite this. We don't have to do anything too drastic to it, but what I would probably do is this condition that we have over here, right? I'd probably just check that first. This isn't going to change the computation of this function whatsoever, by the way, guys. This is just going to change like the visual style of the code. So let me maybe just like drop this down. So we're just going to check this. And then if we look at the original thing, so this has to be true. And then we've got an and then this has to be true, right? So if this is false, then we already end up in a situation where we aren't actually even evaluating this. And we're not obviously returning true. So therefore we're returning false. So what I would do, this might actually make it a little bit less readable, but we need to kind of flip this into a false if we want to return false as an early out. Or alternatively, you could go through this and change all of these into not equal and then and, right? So that actually might add some clarity. So if we express this like this instead, we're basically saying that the tile type has to be one of these. And if it's not any of these, then we can't continue. We have to return false. Another thing you could obviously do is write a function that just checks to see if the tile type is any of the following list. That would also clean this up massively, because instead of doing any of this, you could do, for example, is any type, and then have, you know, your hills and this are over here. And so if the tile is none of those types, then you can just early out and return false. Now, the next step here is to actually check to see if we have a collision between the rectangles, which now we can simply return like this. So this is probably how I would write it. It makes it, I think, a little bit better. Again, if you did have that function is any type, that would also clean this up quite a lot. Anyway, going back to managed collision, we then have process collision, which this stuff seems so game specific to me. I mean, so we have the process collision function here, which takes in a bunch of rectangles, speed, and returns void. So you can see that one of the rectangles we have here is passed in by reference and the others are just passed in by value. Now, one thing I have noticed over here just throughout the code base is the lack of const, right? Like we're not really seeing the const keyword anywhere. Let's have a search. So outside of raylib, I mean, it's used here for this float called size for some reason. It's used here and well, it's used here as well. So we've got three uses, I think, of const. Const is great, not just from like a compiler optimization point of view or like a programming, like preventing you from doing bad things accidentally point of view. It's also really good from a code readability point of view, because it lets me see exactly what's going on with these parameters and it adds a lot of clarity to the function. So as an example, if this previous rectangle had been marked as const, it would just make that much more readable, right? To just be like, okay, this is just being read from, and I'm going to be writing to this because it's passed in by reference and it's not const. Now, do you need to mark this as const? Well, of course not. The fact that it's a copy of that object just already means that you can't really modify it in this function and have the effects apply outside, because the data will be copied when it's passed into this function. Also begs the question of whether or not you want to necessarily copy it. I don't know, it's only 4 floats. It's probably not going to make a difference, but that's just something to note. Now, the other thing that is interesting is that we've chosen to write to other tile here as a response to the collision, I'm guessing. So we're taking the previous rectangle's y and adding the height. So we're checking for a specific edge here. So if we've got this like rectangle, right? We have the bottom edge. And so if that's less than or equal to the player y, so this would indicate a collision like that, or we have the opposite effect of this top edge being greater than or equal to the bottom edge of the player, then I guess we're somewhat vertically colliding and we have the ability to move the other tile by a set amount. Why is this in the utils class in a function called process collision and not like either in the game class or maybe in the scene? There is no scene class, but if there was one, that would be a good place for it. This is not really a utility. This is a major game system. Like, this shouldn't really be here. And also, I really don't like the fact that we actually have like legitimate movement code here that lets us move things. So if we're trying to move forward by pressing a key, we're checking to see if that key is down in a utility process collision function, right? Like, that's really odd to me as well. How would I do this? I would probably have a very specific place in my code base inside like the player class. Potentially we do have a player class. So this is the thing that should handle, I guess, movement. And it is in a way because we're setting a direction over here, but I'd probably generate some kind of velocity based on, you know, whatever the gameplay rules are that would happen when I press a given key. And then that like vector, that 2-dimensional vector in this case, could be passed into whatever mathematical function you need to calculate things like collision response, which is what's happening over here. Instead of polling the input system everywhere in the code base and then mutating that rectangle in that place. We've got like utils, like the harvesting status here and plantable status. I guess if something is plantable, I just don't know why all this stuff is written as a utility, like in the utility class. The utility class is supposed to be very, very, very generic things. You know, I mean, you could have utility classes, and I'm saying class, by the way, this is just a namespace. I don't literally mean a class. I just mean like a set of code, right? These utility files, usually they might apply to like a specific system or concept. So like you might have a file called string utils, which has a bunch of like string manipulation functions. But generally, utilities are things that are very generic and definitely don't apply to the core logic of your game like this. I guess they are in a way generic the way that you've written them, just because they have no state, right? Like they just take in a bunch of parameters, they spit out an output. Sometimes the output is included here. So this is also what I mean. Like there's no const here, so I can't tell. Like is player, I'm guessing player and tile are probably both written to, but why would they be? This is just harvesting status. Yeah, nothing is written to here, right? So this definitely should be const player and const tile, and I mean optionally const rectangle. The reason why I'm saying that it's optional for the value type here is because like if you have a non-const reference, that actually has different semantics to having a const reference. So for example, you can't provide an R value into something that is not const. You actually have to give it an L value because you could write into that memory, and obviously an R value is like a temporary. With a value type, that doesn't matter because whether or not it's an R value or an L value, you're still constructing that object or copying it from a different source into this variable. So it definitely does matter a lot more with references, but that's one of the biggest pieces of advice I probably have in this whole code review, just to get familiar with the const keyword. So yeah, like in general, these utilities are kind of weird to me. Okay, we've got some GUI code here. This is probably gonna draw our UI, which is fine. Like this, I guess this is kind of what I would expect from a small game. This is actually like looking through this kind of makes me want to play the game as well. Like it'd just be nice to check out, you know? So it'd be really great if you could fix it up. I really wonder why this GUI class, which obviously has things like mouse hover and mouse clicked, and it's got all this stuff, why this wasn't used for like the main menu or like for the title screen. That's generally another thing we want to do. We want to reuse systems as much as possible, because then we can actually build like almost like a library of really solid, stable code that has all the functionality you could possibly want to more effectively create content you know, for our game. If we just have stuff like, you know, this game CPP file having its own like title screen UI. Oh, actually look, it is using the GUI class. Oh, but hold on. Oh, but this is, okay. Okay. This is worse than I thought. Okay, so I thought that GUI, this applied to some kind of state, but it doesn't really. It does, but it doesn't. So this mouse hover function, for example, just checks to see if the mouse is hovering on this destination. So there's no reason for this to be a member function. Doesn't use any members. This should be either a static function or it should be, this could be a use case for a utility as part of your utils file or something. It could be like GUI utils, because you can see that it's just getting the mouse position and checking to see if there's a collision with the rectangle, whether or not they intersect, which by the way, you can just straight away return that result as well. And then you've just got a one-line function, which is nice. I mean, it almost begs the question of why do you even have that as a function? I mean, I guess mouse hover might make more sense, you know, when you read it compared to if you had something like this, but you can obviously write code like this just in here and it's the same effect. But yeah, I do agree that this does look nicer and probably like in terms of the English, it reads better as long as you drop this down as well. But yeah, these functions don't use any member variables, so I probably wouldn't have them be member functions like this. It kind of looks like you're just using GUI almost as a namespace, but it's actually a class instance. Yeah, and then we've got like, you know, format zeros, which these all are just like utility functions, right? So here's format zeros. Again, should be static because this is just doing some math on like the input parameters and that's it. It's returning a formatted string. All right, anyway, lots more that we could look through. I think it would probably be a good idea to save this for maybe next time when maybe this will be fixed and we can actually play the game and we can actually see what we're looking at, because that helps a lot compared to just looking at the code. The general design I think is not bad. There's just some maybe lack of experience that's showing through. Generally though, like I honestly, if anything, I'm trying to be more roasty than usual because you wanted roasting. But apart from like code organizational things and, you know, const and whatever on earth this file.cpp file is with the emoji variable name, apart from all of that junk, I think you're definitely on the right track. And I think that this is great. Like this is just a really good way to just keep practicing C++, keep practicing programming, just keep working on this game. Honestly, keep working on this game. It's nice that you found yourself some assets as well that you could use, so you don't have to spend time doing that if you're not interested in actually making your own assets, and you can focus on the programming part. Just keep iterating on this, keep adding features, and this is going to be a really good vehicle, I think, for you to learn programming and improve and get better at it. And to make things even better, you'll have like a nice portfolio piece that you can show off as well. So generally, great work. Just fix the project so I can play it. I'll see you next time.